Hello, welcome to Workshop 7. I hope you are all well. So today's topic is going to be about autonomous driving systems, and namely Apollo. So first we'll try to run it, see how it's done. Then we'll try to look at its interface and interact with it. Basically try to drive around the car automatically. Then we'll try to look at the new version of the simulator, see what is new and some of the issues that were present in the previous version of the simulator, how they got fixed. And then lastly, we'll try to control Apollo with Python API. Okay, so I wanted to show you, just talk about Apollo a bit. So this is actually from the demonstration of a new version of simulator, this presentation. So I will include this link of this file in the chat. It contains a lot of useful links, so it might be useful for you. But this also includes this picture, which illustrates very well how the simulator and Apollo interact with each other. So I will zoom a bit and describe it. So on the left, there is simulator with its environment. So it generates some traffic lights and obstacles and other stuff with also a car and sensors. Then bridge connection is established between the simulator and Apollo. And with the bridge connection, Apollo receives sensor information from the car. Perception module then processes this sensor information, and from the cameras it determines obstacles and traffic lights. Then at this point, if we give Apollo destination where to drive, then planning module with other modules like routing, and we'll see also some other modules, the list of them, route away to the destination, and lastly the control module interacts back with bridge connection to the simulator and tries to drive the car. So this is briefly how this process is done. So now we'll see how to run Apollo. So this is GitHub page of Apollo. It's a code. This is about the naming. And this page basically includes all the information that is needed for launching Apollo, but it includes much more in depth. In case of troubleshooting, this is very easy, and we used it. It was very helpful, but the more shorter version of these instructions is included in the LGSVL page. So it's more useful for us now, so we'll use that one. And so this is, by the way, this is the new web page of LGSVL simulator. Now it's called SVL, just SVL simulator. So okay, let's look at the Apollo documentation. It can be found by the name of Apollo latest. This one. We don't. This page now includes a way to run Apollo, how to build from scratch, also some configuration, how to prepare the system for Apollo. But this is already done here, and it involves a lot of time to build first time. So I'll just go over this without actually executing, and we'll just need few commands to run Apollo. So I'll just go over this. In case you will be using our workstation, you'll need just those comments, few comments that I will show and demonstrate today. But for now, let's see what is needed to run Apollo. So firstly, it requires NVIDIA video card. For now, it works on that, and it should have at least 8 GB of video memory. Okay, after that, a latest NVIDIA driver, then Docker. Docker is a form of virtualization, and Apollo runs from this Docker image. After that, also it's required to NVIDIA to be installed inside Docker. And when it's all done, then the Apollo can be copied from the GitHub, and it should work from this command. And to see that everything is done correctly, this is the command to check it, the NVIDIA configuration. And we should get this kind of image table that shows the parameters of NVIDIA card, and that everything is ready and system recognizes it basically. This shows total amount of video card memory, and this shows the current usage. Okay. So next comes a way to start the image. This is the command, and we'll start from here. I cloned this folder in the downloads folder, so we should just go there. Okay, it says that it's okay. And by the way, first time this is launched, if you will be using your workstation to build it, this will require a lot of time, this command, and also this one, this actually command that builds Apollo. So it requires at least half an hour and may not succeed at first run, but usually succeeds on the second. But we'll skip that command. Instead, we now proceed with the second one to go into the Docker container. We can check, by the way, with the same NVIDIA SMI to make sure that NVIDIA is also installed in the Docker. So next here is a way to add a vehicle to Apollo and also map to Apollo, but for now we'll skip them and come back when we see actually interface of Apollo. So this is next is a way to run a service of Apollo. It's called Dreamviewer. And it returns web address in which can be viewed. It can be viewed. So this is how it looks like. At this point, I guess it's a good idea to run the simulator now to see how they interact. So I'll just run it now. So this is just a regular simulator. Just a car is Lincoln, regular one, and let's run it. Now on the Dreamviewer page, we can select the vehicle, the same one, and map is also already selected. And when we move to the modules page tab here, we should start enabling modules. So first is localization. But it didn't start. Okay, let's see one more time. What can be the issue? Yes. So one more command is needed here to actually enable the bridge, launch the bridge. So here we should actually see here that bridge is connected now. Bridge status connected. Okay, let's go back to Apollo and let's try to enable localization now. Okay, and if we try to just run it, we'll see that this view also copies what is happening in here. So now let's look at how much memory it is using. So now it is using about 3.5 gigabytes of memory, video memory. So let's start enabling all the required modules. It should be here. Which module should be enabled? Here is all the a list of modules. So let's enable them. So for now, 1, 2, 3, 4, 5 modules are enabled, and the usage is about 5 gigabytes. So next, traffic lights. and then perception. Okay, we see that perception module turned off by itself and memory usage just dropped. So we can try it again and see what happens. Enabling perception, and it will turn off. Okay. So basically what is happening here is that the perception module uses too much video memory. And for that, there was a fix introduced that is basically a workaround. So the idea is that instead of cameras to provide an image and then the perception module of Apollo to analyze and get obstacles and traffic lights, we can instead this information, obstacles and traffic lights, is already present in the simulator. So we can provide it with car sensors to the Apollo, and so Apollo still would get this information, and this will help us to test actually other modules of Apollo, like planning, routing, and control. So for that, this is actually in the documentation. It is called the modular testing, this approach, and here is the instructions for that. And it basically includes just these two sensors added to the car. So let's do this now and test it. So stop the simulator. And I have already prepared this car with new sensors, and all is needed is to just add that copy and add that two sensors here, nothing else. So this is actually fixed in the new version of the simulator, the latest one. So I will not do all them in details, all the copying and how it's done. It just we'll just use this one now. So in the simulator, we'll just change the car. And let's try to run it again. And that new car should now include also traffic lights and obstacles. So let's see. And now we can see that in the dream viewer, actually, this information, this car information is already included with the localization. It comes with a localization. So we'll just restart all the modules, rest of the modules, and try to drive the car now. Okay, so on the left, some other tabs got enabled. So we need the routing tab, this one. And now we can select any location, for example, here, or it can be here, and click this send routing request. And already it wants to go. As soon as we enable control, we should see that it should go, the car should move. Okay, so it stopped on the red light, and when it didn't have any obstacles, it tried to cross the road. Okay, so this is how it's operating basically. Now we'll try to do the same with the new version of simulator. Let's just turn it off. And try to run the new version. By the way, to get it, just you need to just download it from the main page of the SVO simulator, but I already have downloaded it, so just requires to launch it. So this is how it looks like. Some of the changes. So the principle is the same. We have like maps, vehicles, and now in addition plugins. I will talk shortly about it. And then the simulations tab. So some of the changes is that we don't need to go to the web page anymore to add new maps. We just there is a store here with maps. We can just select any, and it will be added. Just click plus, and it will be added. Also, there is a way to also share. So it is all in the cloud now. So it enables us to share with others and also view theirs also the simulation. Okay, so this is a new part also. In addition, now so in order to use a new configuration of sensors, we don't need to add new car with the same name. We can just add new configuration of sensors to each car. So now this car, for example, Lincoln, it has a lot of different kind of sensor configurations. Like one is Apollo 5 full analysis, and there is a keyboard control, like Apollo 5 modular testing, for example. And now also we can add new sensors from here. There is no need to deal with JSON format anymore. For example, we can create one right now, like test one, and cyber create, and now it gives us list of all the sensors, and the JSON code is added automatically, so there is no need to like copy them anymore. But we won't create it right now. We just we can now use sensors that already come out of the box with a simulator. Okay, so first thing we need to do when we get here is actually to create a cluster on this tab, and what it does is basically, because now this page is not locally, but it's from the cloud, from internet, we need to link our application of simulator, this one, and this page. So first thing will be to it will be empty, no names should be here, and it will ask us to name this cluster and finish the configuration. And after clicking it, it should this application should get linked. Okay, so let's move to the simulations tab, and now we can explore how this has changed. So let's edit already existing one. For example, here is a name part. Here is the cluster, basically name of this computer. And the next will be just map here, car. Here will be configuration of sensors, traffic, and this is already familiar for us, so I won't go into details. And this is the configuration of the bridge. So now let's run it and see how it interacts with the Dream Viewer. Should be the same. So the rest, Dreamweaver will do the same. There is no difference in any regard, in any other way. Okay, so next thing I want to focus on is how to add the map to Apollo, because here it only has very few maps, and there is instructions how to do it on the page, on documentations. We skipped it. Here, and in here there is these instructions, but the easiest way to do it is, I guess, so basically how it's done is from the page we can take like select any map, for example this, then download its file, base map, and from that file generate two other files and include in this location in Apollo's folder. So let's check it. So this is a folder. Here it just requires any map with the name, and inside files, like for example these three files. So we get this file from downloading as I showed you, and generate these two with these and these. But there is another way to do it, because this method requires, if you're doing it on your workstation, like from scratch, it requires a lot of libraries, which a few of them are not included in the apt repositories, so they require building from the source, so it can be, I guess, time consuming. So easiest way to do it is from GitHub, fifth version of Apollo, because more maps were included in that version, but not in sixth version. So let's do it now. Copy. We can I can show you how to find it. We can check the same location, modules, map, and data. And here we see that it includes a lot more maps. So I actually have downloaded already. It's in my my folders somewhere should be. I think it's in downloads. So let's copy it. This is the archive. Modules and map. So for the next and last section of this workshop, I will be using San Francisco map. So let's download the San Francisco map. Yes, by the way, after that, Apollo needs to be restarted. So let's stop the service and restart it. Let's try to just stop the service itself, not the image. Try to see if it works. So maps and data. As we see, it comes with those three files. This and this one just comes as the bonus, but they, as I noticed, they're not required. Okay. So let's try to restart the service and see if map is added, was added here. Yes, San Francisco was added here. Okay. So the last part I wanted to show you is how to interact with Apollo to Apollo with the Python API. So for that, we'll need the Visual Studio Code, and so this is the code. This part is not needed for now. The starting of this file of this code is nothing new. You already know that. Apollo part is just this one. This adds a connection, bridge connection to Ego vehicle. Then we create variable of Dreamviewer of Apollo and initialize the connection. Then we set the map, we set the vehicle, and then make a list with all the required modules that we want to activate. Then we set destination. I picked any destination just 400 entities forward because it's hard to, without visual interface, to pick any other location other than forward or left or right. It can't be like around the corner because it's hard to know where the corner is, and because the streets in the map doesn't have any names, so it's hard to pinpoint any. So I chose just this one, and then we give the Apollo this variable. all the things that we just configured, modules and the destination coordinates, and then run the simulator. And so let's see what this code does. The first part, not the Apollo part, but the first part was just regular creating connection, SIM connection, picking map, like spawning car, and adding a collision method. We already know all that. Okay, so let's now run the API only simulator here and test our code. As you see, automatically all modules got enabled, and maps and car also got picked, and destination was also set. So car just began driving. It still stops at traffic lights. So I'll tell you just why it's so convenient, the benefit of controlling Apollo with Python API, because if we look in the code, it should give us a way to like interact with the environment with the simulator while the code is executing. For example, like create some obstacles for the car in front. So I'll just show you like what I'm talking about, but this is basically more next next workshop topic. So it will be explored more deeply. I just show what's the benefit of Python API controlling Apollo with it. So let's restart. So some pedestrians appear in front of the car, so it tries to let them pass, and then continue its way. Okay. So I guess the homework should be about reproducing this code. I won't include this anywhere in the documentation, so you can do not this one because this is not part of this seminar, but just this part and this part. Just you can let the Apollo drive the car, like create some vehicle and try to automatically give destination and make it drive somewhere, basically. That should be homework. So that was all I wanted to talk about today. So thank you.